go. Planet Measure 8.
All right, back at it. I got the same shirt on. It's not day 2. I'm just keeping this thing rolling. Trying to keep it live with some gorillas. Okay. All right, let's get into this, folks. Okay, so you can see what I have up here are the learning goals. And I didn't talk about these all in my first lecture, but now I'm going to bring this to your attention. This is it right here, folks. This is the list of stuff I want you to know. I got one of these for each chapter. This is your study guide. And occasionally I'm going to go through this and see what we've done and see what we haven't done. Okay? So what did we talk about in the last lecture? So distinguish a substance as an element, molecule, compound, and or mixture. Yep, we definitely talked about that. Okay? So let's see. Can I highlight that? Yes, I can. And I'm also going to point you out to the back side of this page. Then this is on the canvas, all right? If I go all the way down here on this next side, if I were to take a test on this subject today, I would feel. And now look at this. Here's that learning goal number 1 that I just highlighted above. Well, how do you feel? Which category are you in? I would encourage you to have this document out and check these boxes right as you go. Maybe that first lecture, no way you're ready to take a test on that one learning goal because you just watched the first lecture, of course. So then maybe you get some more practice, you're feeling good, and after you've had enough practice, then you move on to that category. Great, let's do this thing, okay? So keep track of these learning goals as we're going. Let's go back up to the top here. So identify a process as a chemical change or a physical change. Yeah, 100%. We did that in the first lecture, okay? Calculate the density of a substance given its mass and volume. So we didn't quite do any calculations with this yet. I showed you how to use the formula, okay? But we're going to get into some more examples of this. So I'm not going to check this one off yet. We did kind of talk about it a little bit, but after we've had some examples, maybe we can revisit this, okay? So identify the correct phase transition a substance goes through given its respective phases. Yeah, we definitely talked about that. Okay. And then now the rest of these, as you can see, these probably don't look very familiar. That's because I'm going to talk about them right now in this lecture. Okay. So we'll come back to this and see how we're doing. All right. So here we go. I've got now my lecture slides that we're going to continue on. Let's do it. Okay. And if the air horn gets annoying, I don't care because I love it. All right, so section 1.8 out of your book, SI units. Okay, the fundamental SI units. That stands for System International, and so this is used all over the world. And contrast to most of the stuff the United States does, right? We're going to use pounds and inches and all that junk. We have this organized way. We have a set of units that the entire scientific community across the world uses so that we don't have to be like, oh, you guys use pounds and you guys use this and you guys use that. If you're a scientist, we all use the same units, all right? Mass, the kilogram is preferred. The kilogram is considered SI, okay? Although in this class, we will use grams quite a bit because in chemistry, you rarely ever have like a full kilogram of something. A kilogram is about 2.2 pounds, so that's quite a bit, okay? So we'll see grams quite a bit, and we're also going to talk on the next slide how we convert from the kilogram to the gram. Okay, length, the meter is preferred, okay? But we note that centimeters, kilometers, millimeters, all of that will be a part of this base meter. Okay, just like a gram is part of the base unit kilogram, or SI unit, really. Okay, so time, seconds, right? Don't need to spend too much time there. Pun intended. So volume, this is a tricky one because a cubic meter is considered the SI unit, but a cubic meter is actually kind of gargantuan. It's kind of a big volume for chemistry. So we will typically use the cubic centimeter, which we remembered from the last lecture that's the same as the milliliter. And we'll talk about how to interconvert from cubic meter to cubic centimeter. Okay. Amount of substance, the mole. We're going to spend a whole bunch of time talking about what the mole is. So stay tuned. So SI unit of force is the Newton. Okay. We really won't do much of that in this class. That'll be more relevant to your physics class. We will use energy units quite a bit, and that's the joule, J for joules. Okay. Temperature will almost exclusively use the Kelvin scale, although you should be familiar with Celsius and Fahrenheit and how to interconvert between these three. And pressure, our SI unit, is the Pascal. Okay, and we're going to get into that in a lot more detail in due time. Okay, so moving right along. So here we have the commonly used prefixes for SI units. Okay, there's a whole bunch of them on here. The ones that I have highlighted on this list and that I'm checking through here are the ones I want you to know for this class. Okay, all of the others, you know, you can memorize them if you want, but you don't have to. All right. But these yellow ones are the ones I want you to know for the class. Okay. So for example, if we look, so this kind of line right here, I'll draw a line. Let's see if I can do that right through here. And really what this line is referring to is, I'll call it the 1 line. Because now if you notice, look, 10 raised to the power 1 is 10. Okay. 10 raised to the power 2 is 100. And then, as you might guess, 1,000, a million, a billion. So then now if we keep going down here, okay, 110, this line is 1. Then 10 to the minus 1, that's 0.1, so you can see it right there. 10 to the minus 2, 0.01, and so on and so forth, right? Okay, so we're going to get practice on how to use these. But I want you to recognize here, the giga, the mega, and the kilo, those are big. When you have a kilogram, you have 1,000 grams. So that's a lot. If you have a gigagram, you have a billion grams. You have 1 times 10 to the 9th power grams. So that's humongous. So these are the large quantities. These are the small quantities. Okay. So deci is 1/10. Centi is 1/100th, right? 1 over 100. Milli is 1 over 1,000. Micro is 1 over 1,000,000. Nano is 1 over 1,000,000,000. And pico is 1 over 1,000,000,000,000. Okay, so be very comfortable with this kind of conversions. We're going to get lots and lots of practice. But if there's any area of the course that you're nervous about so far, and if this is one of those areas where you're nervous, practice makes perfect, right? So I'm more than happy to help you practice through interconverting here. Okay, and a couple more slides, and then we're going to have an opportunity to practice. Okay, so here are SI units, and then of course their US customary unit equivalents. I don't expect you to have any of this memorized. You don't have to memorize any of this stuff. These highlighted things you do need to commit to memory. These you don't. I'll always give you conversions, all right? So for example, I think I said earlier 1 kilogram is about 2.2 pounds, okay? And you can see all these other conversions, right? And we're gonna learn how to use these, okay? I don't expect you to memorize these at all. But you will want to be able to look them up when you're doing your homework problems. And have them, you know, handy where you can find them, okay? So let's talk about volume. Okay, so here I have a box, and as it turns out, this box is 1 cubic meter. So it's 1 meter by 1 meter by 1 meter, which you can see that's right there. And I'm going to use this volume example to show you how we do math with units, because doing math on the number is important, but doing math on the unit is also important, okay? So here we have 3 meters, 1 meter by 1 meter by 1 meter. That makes a cube. Literally, it makes a cubic meter. Okay, so now check it out. I'm going to count these boxes here for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of these boxes, so I'm going to draw like this arrow right here. So that's 1 meter, which actually equals 10 decimeters. And if I back up for a second, look, deci was 0.1. So to get a full meter, I need 10 of these. 10 times 0.1 equals 1. Okay? So now you can see that 1 meter is the same as 10 decimeters. That meter is the same as 10 decimeters. And that meter is the same as 10 decimeters. Sorry, this got cut off a little bit, so that's 10 decimeters. And so now look, when I do this math, 10 cubed is 1,000, okay? But a decimeter cubed is a cubic decimeter. So 1,000 cubic decimeters is the same as 1 cubic meter. All right? And so now we can't draw enough of these to get to a cubic centimeter, but hopefully you can see where this is going. And also, by the way, you notice here that when I have 1 cubic decimeter, that's the same as a liter. Okay? That's kind of cool. So 1 liter is 1 cubic decimeter. All right? So, but now, if we back up 1 second here, so we notice now that 1 centimeter is 1/100th. So it would take 100 centimeters to make 1 meter, right? 100 centimeters and 1 meter. And so here we can see that, and that, and that, right? 1 meter is 10 decimeters, which is 100 centimeters. And if I do 100 by 100 by 100 centimeters, that's 100 to the power 3. Plug that in your calculator. 100 to the power 3 is 1 million. That is 1 times 10 to the 6th power is the same as 1 million. Or if you recall, here another way I can write 100 is 1 times 10 to the 2. And if I cube that, right, 2 times 3 is 6. 1 times 10 to the 6th, okay, to give me 1 million. And then a centimeter cubed is a cubic centimeter. And hopefully you remember that a cubic centimeter is the same as a milliliter. So 1 cubic meter equals 1, oops. So 1 cubic meter equals 1 times 10 to the 6th milliliters. So there's 1 million milliliters in 1 cubic meter. Okay? Great. So I think I can move on from there. But the important thing to note here, I'll write down, if you cube the number, you cube the unit. So whatever arithmetic we do to the number, we do the same arithmetic to the unit. Okay? All right, so here's a bunch of examples that we can practice. Okay? And what I'm going to do, I'm going to walk us through these calculations. I'm going to play a little bit of music in the background while I'm doing it. You are welcome to just even pause the video and try these calculations out for yourself, or you can kind of watch me work through these while we're listening to some chill music here. Yeah, and then we can talk about the result after that. Okay, let's get it going.
motion, double devotion. Push peace and keep it in motion.
You know, I wanted to say I got a little too funky with this. Getting all excited about listening to my music, I forgot to kind of describe my process. So I'm going to draw a picture over here when we do unit analysis. And that picture is, I'm going to start here. I'm going to draw a circle. This circle represents the number in the question. Okay? That's what we start with. We start with the first number we're given. And in this problem, how many kilograms are in 1 teragram? Well, we were only given one number to begin with, so that's where we're going to start, with 1 TG. We're going to start with whatever number we have. And then the process is going to be a series of multiplications and divisions. And the pattern that I like to do is to start at the top and go to the bottom. And then go up, and then go to the bottom. And then go up, and then go to the bottom, and then go up until I'm done. And how do I know when I'm done? Well, I know when I'm done because I end up with the unit that I want, okay? So, for example, let's walk through this one, and then maybe I'll also walk you through B, and then we'll go back to the gorillas for part C and part D, okay? So I'm going to start with that 1 teragram like they gave me. And now my goal is to go down. Well, what am I going to put down there? I want to put the exact same unit, 1 teragram, okay? And I'm going to do that because now when I divide this teragram by this teragram, that's going to cancel that unit out, okay? And so what am I going to put up here? Well, the best thing you can put up here is the gram. And now we're going to write that definition that I got from right here. So I can see 1 teragram is 1 times 10 to the 12th grams. I know it's not on the list of things I actually memorize, but we can still, in this case, use this sheet to help us calculate it, okay? So now I need the number of teragrams that are in 1 gram or vice versa, okay? And so I'm going to say in 1 teragram, there's 1 times 10 to the 12 grams, okay? So now I've gone down and then up. And then now I got to do it again. And so now when I go down to this way, okay, I'm going to write grams because I want that to always be the same so that my gram and my gram unit can cancel. And because I'm trying to get to kilograms now, and I look back here on this sheet, I can see, oh yeah, I know that a kilogram is 1,000 grams, okay? So now I can say there's 1,000 grams in 1 kilogram. And then now when I look through this, okay, the teragram and the teragram, when I divide that by that, it cancels. And when the gram and the gram, when I divide that out, it cancels. And then now I'm left with kilogram, so now I know that I can stop. And then I've done the math on the units already, right? I've divided out the units like I need to. Now I have to do math on the numbers. And so this goes 1 times 10 to the 12th divided by 1 times 1 divided by 1,000. You'll recognize all of those ones, right, don't matter. I mean, they do matter for the units, right? But for the math, we know 1 divided by 1 is just 1, right? So it's really just 1 times 10 to the 12th divided by 1,000. Okay, I'm going to try to show you a cool little trick on your calculator because I know a lot of you are going to want to enter in 1 times 10, 12. Okay, so I think I can do this. Yeah, here we go. I'm going to say 1. I'm going to use this double E button. E 12. So that gives me the equivalent of 1 times 10 to the 12. And now I'm going to say divided by, oh, this is hard to do, 1,000. And if I count all those zeros, 1, 2, 3, 4, 5, 6, 7, 8 zeros. And look, if I move my decimal place, 1, 2, 3, 4, 5, 6, 7, 8. I can't count and do this, but you have to trust me that it's 1 times 10 to the 9. Okay? So that gives me 1 times 10 to the 9, and then the unit that's left is the kilogram. Okay? So let me put a different color on this. Okay, so remember, I started with the number that I was given. Then I went down to that unit, and to go across and up, I need to use that conversion sheet. Okay, and then from the gram, I went back down and kept the gram, and then I used the conversion sheet to go back up there, and I was left at the same number. Okay, so let's try, I'll walk you through this one, this part B. And then I'll work through C and D on my own. Okay, how many nanometers are in 6.5 times 10 to the 2 terameters? Okay, so how do we start this thing? Well, we start with the number we were given. In this case, 6.50 times 10 to the 2, and that's a terameter, TN. Okay, so automatically, without question, I know I'm going to go terameter, and I'm going to put a terameter down here, and then I'm going to put a meter up here. And I could even finish this off like to the end game, right? I can then know that the next thing I'm going to have to put down there, I'm going to follow this. I'm going to say meter. And then it's asking me for nanometers, so I can go meters to nanometers. Okay, so from the first one, right, we remember a terameter is big, so that means 1 terameter is 1 times 10 to the 12 meters. But what about this nanometer? So a nanometer is really small. There it is. It's 1 times 10 to the minus 9 meters. So there's a couple different ways that I could write that. Okay, I could say in 1 meter, there's 1 times 10 to the negative 9 nanometers. Or I could have said there's 1 times 10 to the positive 9. Oh, wait, hold on. I messed that up. Make this a positive. Yes. Let's erase that and try that again. Okay? In 1 meter, so I'll back up for a second. Because a nanometer is small and a meter is big, that means there has to be a lot of these and only one of these. Right? Yes. Okay. Yes. Sorry, I just cheated. Okay. It's the first day. I'll forgive you for your mistakes if you forgive me for my mistakes. So yes, so we know that a terameter is much bigger than a meter, and same, a meter is much, yes, a meter is much bigger than a nanometer. So these all check out, all right? And so now I can say terameter cancels with terameter, and meter cancels with meter, and I'm left with nanometer, which is what I'm trying to get to. Okay, equals. And so now my math is going to be 6.5 times 10 to the 2 times 1 times 10 to the 12 times 1 times 10 to the 9. And that's going to give me a big number. That's going to give me 6.50 times 10 to the 23 nanometers. And that makes good sense because a nanometer is really, really small and a terameter is really, really big. So it makes sense that we would have a really large amount of nanometers to fit in a terameter. Okay, so I'm going to play the music and work on these next two on my own. So you're welcome to pause the video and try it for yourself, or you can work alongside with me.
Kids gather around, yeah, I need your focus. I know it seems like the world is so hopeless. It's like wonder. Fascinate me, picture and animate me, 'cause I'm ball. Boss, yo, give it to us. Get it all. Turn it up. Speed it up. Slow it down. Underground way under us. Undercut. Shipped up. Shipped out. Swimming with the shorts with the fuse up. Turn the wheels up real tough. Drinking lemonade in the shade. Getting laid with a gang of pills left. Yeah, this my path. They be popping like a mama rocking in the bubble bath. And I'm just like that. Ozone ready up to get you more cash. Yeah, so quick, so fast. All the kids say they love me when I'm not last. Welcome to the world of the plastic beach. Yeah. Welcome to the world of the plastic beach. Welcome to the world of the plastic beach. Yeah. Welcome to the world of the plastic beach.
Okay, we got to another interesting one here with volume and these cubic decimeters, okay? So whenever we have a volume, we first want to use the distance version, okay? So I'm going to put just a decimeter, even though what I know I really need is a cubic decimeter. So I'm going to put decimeter down there. And I know that then what I do across that line is to go to the base unit, okay? And let's deal with this first before we move on, because I got to make this a cubic decimeter. Well, I know that there's 10 decimeters in 1 meter, okay? But now look what I can do. I'm going to put a parenthesis around this whole thing and cube it. Cube it. And so now when I cube this, that means I'm going to have in 1 cubic meter, there's 10 to the 3 cubic decimeters. So remember, if I cube the unit, I have to cube the number, okay? So you could apply that 3 and recognize that that's got to be 10 to the power 3, 1 to the power 3, m to the power 3, dm to the power 3. And that'll give us that'll cancel the cubic decimeters. But now you have to note that we have a cubic meter on top there, right? So that's going to be a cubic meter down below. And let's see here. If you recall from our conversions, here we go. 1 cubic meter equals 1,000 liters, okay? So let's keep going with that. So 1 cubic meter was 1,000 liters. So now my cubic meter and my cubic meter is canceled, and I'm left with liters, and I can calculate all the way through. And when I do that, I get 8.0 liters. Haha, so maybe you remember this sneaky little thing here, 1 cubic decimeter equals 1 liter, okay? So that's all we did. We just proved that, right? We got 8.0 cubic decimeters is 8.0 liters, okay? When I do 8.0 times 1,000 divided by 10 to the power 3, because 10 to the power 3 is 1,000, okay? So moving along here, okay, so now I want to talk about significant figures. And our significant figures are going to be really important in this class, as well as like the rest of your science classes, okay? So I'm going to walk you through. So here's all of the rules. Instead of like reading you all these rules, we're just going to walk through some examples, okay? So I'll just kind of hit on these very briefly. So there's non-zero integers, there's zeros, and there's 3 different types of zeros, and then there's exact numbers, okay? So anything that's non-zero, so 1 through 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, are always significant figures, okay? But zeros, it depends on what they are. So a leading 0 does not count as significant, okay? So a leading 0 is anything that precedes a non-zero digit or a decimal. So for example, right here, okay, we have 0.0025. The leading zeros don't count. So in this number, 0.0025, there's only two significant numbers, and that's the 2 and the 5. Okay. Captive zeros are zeros between non-zero digits, and they definitely count. So 1.008, for example, has 4 sig figs. Okay, and then we have trailing zeros, which are the end of the number, and they are only significant if there's a decimal point. For example, when you write 100, excuse me, when you write 100, there's only one significant number. Okay? But if I write 100 point, now these two zeros count now. And I know this looks really goofy to write 100 like this, but this is legit. This is how we do it. Okay? But also, if you wrote 1.00 times 10 to the 2, that also has 3 significant digits because the zeros following the decimal point count as significant. And then finally, we have exact numbers. And exact numbers count as things that we can count up, like 10 experiments, 3 apples, or 8 molecules. Okay, I'm going to go ahead and stop the video and finish the rest of these slides in a third video. Okay. All right, folks, I'll see you at the next one.